Okay, Assalamu alaikum warahmatullah and good afternoon. For today, we are going to continue our class about the database design. So we have already taken the description about the database
Doctor,
design phases.
can you be louder? I can't really hear you.
Yes, okay. Last classes was all about the description of the database design phases, the explanations of on how to construct or how to build the entity relationship diagram. And for today, we are going to continue with the transform of the entity relationship into a relation. So after we build the entity relationship, how we should do with that diagram and how we translate it or transform it into real relations. Okay, so this is the most important step of the design. Then after that, we should learn about the normalization to decompose a relation with anomalies. So this normalization is going to optimize and to improve the design of ours. And for today, as I mentioned, is all about the transformation. Before we learn the transformation, we should understand what is the relation. We should understand what's the relation, its definition, and the requirements of the relation. So the definition of the relation is a relation is a named two-dimensional table of data. So any relation actually is formed as a table. Okay, so the relation is not the relation that we create between the two tables or between three tables. Actually, the table itself is called a relation. Okay, why a relation? It's a relation between some data. So for example, if we have like the example of yesterday, we have a car, right? So the car has a plate number, model, and year. All of these three informations are related to the car. So this is a kind of relation, right? So this is what they call it, the relation. So car entity is a relation, accident entity is a relation, the customer entity is also a relation. Okay, but here in the first stage, we learn how to build them as an entity and what they call it, how to create their attributes and so on. And after that, how to create the relations between this entity and the other entities and so on. But for today, we are going to understand how to translate this entity into a relation or into a table. Then that table should be also connected to other tables using relation. Okay? So it's a bit confusing. For today, when we say relation, that means table. So a relation is a named two-dimensional table of data. What is the meaning of two-dimensional table of data? That means when we have a table, it's something like this. So maybe we have plate number, maybe model, and year, right? So this is one dimension, and the data is the other dimension. So here we have the first car, the second car, third car, fourth car, and so on. So that's why it's called two-dimensional. Okay. The table is made up of rows, which is called records, and columns, which is called attribute or field. So every column is called attribute or field. And the row is an instance of the entity. If you remember, we have something called entity type and entity instance. So if the entity is car, so the type is the car itself, the car type. So every car should have plate number, should have model, should have year, right? But after that, if let's say we took the first instance of the car type, It could be, for example, myv, or maybe Burdua, whatever, and the plate number is, for example, ABC 1234. Then the year is 2019, for example. Then the second instance it could be, for example, ABC 3456. For example, the plate number and the car is, for example, NASA. Then the year maybe 2017. So this is another instance, and so on. So maybe the other instance is Mazda, the Ford is Kia, maybe the other instances are different cars, or maybe different models, or whatever. But every model, every instance will have something unique, which is the primary key, right? So here is what they call it. Table is made up of rows. So every row is considered an instance. And the row, they call it record. And the column, every column, which is, for example, the plate number or the year or the model, it's called attribute or field. Okay. The second point here, not all tables qualify as relations. I don't know why they put it here, because this one is really confusing for you. The other point, I just want you to forget about this. Just forget about this, because this one is not your, it shouldn't be your concern now, okay? Because your level now is still at the beginning. Okay. The requirements, the first requirement is that every relation has a unique name. So every table must have unique name. So if we have, for example, let us go back to our tables here, to our design. If this table is called cars, then we cannot use the same cars for another table, right? So every table name should be unique. This is the first requirement. The second requirement, is that every attribute value is atomic. What does that mean? Atomic means it has only a single value. Only a single value. Okay? So here we have to remember, based on our design here, based on our design of what we have taken before. Please close your mics, please. Close your mics. Close your mics. Open it only when you have a question. Okay? So here, if we open this, we can see that we have a field here, or attribute, with multiple values, right? Multi-valued attribute, as you can see here, multi-valued attribute. This is not possible when we go to create a table. In every table, every attribute, the value should be atomic. Should be atomic. Atomic means only single one value, one single value. Okay? So not multi-valued, not composite. As I mentioned yesterday, if you remember, yesterday when I create this, the name, I told you the name is composite, then we have first name and last name. But when we create the table here, when we create the table, we create only the first name and last name. We cannot create the name, then we say that the name is composite. It cannot happen. Okay? So no multi-values allowed, and also no composite attributes are allowed. Every row is unique. Every row is unique. Why unique? Because it has a unique primary key. Cannot have two rows with exactly the same values for all their fields. So when we say that table is having some records here, and every record is unique, so maybe all fields other than the primary key are the same, maybe. Okay, maybe all fields other than the primary key are the same, but the primary key will never be the same, right? Because the primary key is always unique, must be unique, right? So there's supposed to be at least a difference of the primary key value between every record and others. Okay, so here every row is unique, cannot have two rows with exactly the same values for all their fields. So at least the difference will be the primary key. Then attributes or columns in tables have unique names. Yes, this is another thing. So if we go here, if the attribute, this attribute model is used here, we cannot use the model name for another attribute. We cannot use it, but we can use the model name in other table. That's okay. In other table is okay, but if it is the same thing, if it's the same attribute belongs to the same entity, then it shouldn't be used in different table. Shouldn't be used in different table. Okay. So the every single data should be saved in only a single place, in a single table. We shouldn't have the data replicated or maybe duplicated in multiple tables, unless we have a relation that enforces us to have some kind of repetition, like yesterday example. Okay, so here attribute columns in tables have unique names. The order of the columns is irrelevant. So the order of columns, which one is first or which one is last, is not a matter. You can put the primary key at first here as a plate number, or maybe you drag this plate number and you put it at the end of the list. Is not a problem. It will work exactly the same, no matter where is its place. Is it at the first column or at the last column? No issue. The order is no issue. Okay. The order of the rows is irrelevant. Also, if the row is saved at the beginning of the table or saved at the end of the table is not a matter also. It's not going to affect the performance. It's not going to affect the priority of processing the data or whatever. So the sequence or the order of columns and the order of rows is not a problem, not an issue. Don't worry about it. Okay, don't waste time sorting or ordering the columns and ordering the data rows and so on. Okay, don't waste time. Okay, let us come here to this slide. What is an atomic value? This means that in your table, for every row by column, what is the meaning of row by column? Row by column is a cell. So this cell actually is a row by column. Okay, so this cell is a row by column. Okay, for every row by column position, which is called cell, there exists only one value. Here or here or here, it's supposed to be only one value. Okay, not an array or list of values. Okay, so let us think about this table. Is this table correct? Is this table correct?
No.
Yeah, we have one issue that has two sub issues, which is the item here. Okay, the item column name is plural. As I mentioned, the table name is supposed to be plural, but the column name is supposed to be single. Okay, singular. Yeah, the name here is supposed to be item, not items. And here inside this cell, we have a list of items, and this every item has name and quantity. Okay, so it's an array of values or list of values. This one is also two values. One is the name and the other is the quantity. This one is also the same, the same, the same, the same. So all of these are not correct. For here, the date is correct, the customer ID is correct, the order ID is correct. So here also we cannot have something like 23 and 25, for example. in the column ID, in the customer ID. Cannot be. Okay, only one customer at a cell. Any question in this regard?
Oh, no.
Okay, so keep in mind this table, just remember it, and let us go directly to the second slide and see how it's supposed to be. So here for the order number 1, which is belongs to the customer ID number 4, at the day of 4th of November, it has one row here, right? Only one row, but it has 3 items, right? 3 items. Let us see here this order number 1 for the customer ID number 4, which is the same here, number 1 and customer ID number 4. In the 4th of November, it has now 3 records, 1 record for every item. And here, this name is supposed to be item, okay? So this name of columns must be always single or singular. Okay, here we can see that these 3 are belongs to the same order, to the same customer ID, under the same date. But here we have 3 records with different items, and every item have a quantity in front of it as a separated column. Okay, so this design is okay. Now it's better than the first one, because the first one cannot be transformed, or it cannot be created in the database this way. And if we want to create one column here and we save it, this information as a string inside one column, then we lose the main benefit of the database, of using database and using database driven or data driven applications. So this is will be actually very complicated, and will require a data processing, too much data processing, to find how many items we have in this field. Then we have to extract the information of the quantity for every item and so on. So this is not a good idea at all. Okay, so here for this slide we improved the design, but if you remember yesterday I told you about the minimization of the data repetition. Okay, so here we repeat the order 3 times, and the order with the customer ID also repeated, date is repeated, while in reality the order number 1 should have the information of the customer and the date. So we shouldn't keep this here. These fields shouldn't be kept here. Okay, this field is supposed to be shifted to the what they call it, to the master table of the order, because the order has a master part and details part. Okay, so the master part will include the order number, the customer information, name, ID, date, and whatever, or maybe the salesperson or whatever. It's supposed to be in the order master file, and also the summary, which includes the total, the maybe the what they call it, the discount, and also if there is a tax or any other things, and the net of the order supposed to be at the master file. Then the order details should include the items and the quantities, the prices, and everything. And if there is a discount for a certain certain item, it's supposed to be saved in the order detail. Okay, any question until now?
No.
Okay, for this record, because this order is only here having one item, then it will be only created as a one row that includes one item with only one quantity. So I think the rest is clear, no need to waste time. Okay, another example. Can you tell me what's wrong with this?
The employee number.
Yeah, what happened to the employee number? The name is singular.
Mm, no, I mean the information below it, the 20,000.
Yeah, the cell includes multi values. Includes multi
Multiverse. Yeah.
values. And while the cell is supposed to be an atomic value, right? Also this one, the employee name, having also multiple values, which is also not acceptable. So in this case, this row, this row actually is going to be translated into 3 records with the same department number and the same manager number. So department number is 101 and the manager number is 1, 2, 3, 4, 5. We can see here, we can go here and we see how many records. It's 3 records with different employees. But also here we have something else called repetition. So here, once we have the employee number, if this is the employees table, if this one is the employees table, let's say this one is the employees, okay, employees table. So in every record we should have the employee name and also the employee number, but we shouldn't have the manager number because we should have the department number, but based on the department, every department should have a manager, right? So the manager number is supposed to be shifted to the department table, okay, and the department table is supposed to be created this way. I will create it now. So we'll create it very simple, like this, okay, to make it easy for you. So here the depth number, and here the manager number, okay, and here we supposed to have department number like that, and manager number, and also the other department with another manager number. Okay, so in this case, this data that belongs to the same manager under the same department is not going to be repeated. Okay, so we should minimize the data, right? As I explained yesterday. Okay, so I'm going to delete this. Then here we have something called correspondence with entity relationship model. Relations or tables correspond with entity types and with many-to-many relationship types. Okay, so rows correspond with entity instances and with many-to-many relationship instances. Columns correspond with attributes. Okay, actually this is what we have explained before. I'm not going to waste time here. So the column is attributes and the rows are instances. This thing many-to-many and this kind of confusing information for you, I'm not going to consider now, okay? But I already explained everything in this regard, okay? Then we have something called key. The keys are special fields that serve two main purposes. The first thing is called primary key, and the second thing is called foreign key. We have only two keys, two types of keys, the primary key and the foreign key. Primary key actually is a unique identifier of the relation, or unique identifier of a table. So in every table we must have a unique primary key. Okay. So let us read this. Primary keys are unique identifiers of the relation in questions. Examples include employee number, social security number, maybe matric number, or maybe course ID for the course table, maybe the car plate number for the car table, and maybe the employee number for the employee table, and so on. This is how we can guarantee that all rows are unique. Because of this primary key, every row should be a unique combination of data. Okay? For the foreign keys, they are identifiers that enable a dependent relation on the many side of a relationship to refer to its parent relation on the one side of the relationship. Okay, I'm going to explain this because this one is a bit confusing for you. So I already explained this before, but maybe we need to draw it to keep it in mind very clearly. Okay, if let's say this is a table, okay, and this table is what they call it, strong type, strong type, and this is another table which call it weak type. Okay, so if let's say this field here is a primary key, and here the primary key could be one or two fields. Maybe this one is the primary key of the table, and maybe here is a foreign key. Okay, the foreign key is the part of the relation involved or connecting the weak table to the strong table. So the side of the foreign key is always many, and the side of the primary key is always 1. Okay, is that clear?
Yes.
Yes.
Yeah. So whenever we have a one-to-many relation, one side of the relation should be foreign key and the other side of the relation should be a primary key. But if we have one-to-one, this one is called one-to-many. Okay, but if we have another relation which is one-to-one, one-to-one, as I mentioned last time, the one-to-one relation is only to extend, right? So one is primary, if this one is the primary, and this is the secondary. Okay, so this side comes first. This side could be exists, while this side it's an optional. Okay, so the primary key is supposed to be here. Primary key is here, and also this field is a primary key which includes the same name of this field. So these two fields, these two primary key fields in the primary and the secondary tables of the relation of one-to-one may have the same table name, may have the same may have the same column name, or may be different. It's up to you. It's optional. It's up to you. It depends on the meaning. Sorry, I'm having cold and flu. That's why I'm really struggling. Yeah. Okay. So these two tables as I mentioned, are extensions. The secondary table is an extension to the primary table, and both of them have primary key. This primary key could have the same name of the primary key of the primary table or the master table, or it could have different name. But at the secondary part, secondary table here, the primary key is also a foreign key at the same time. The primary key is also a foreign key at the same time, and this foreign key is belongs to here. But because this one is a foreign key, we cannot say that this one is many. This side is one, but this side is not many. Why not many? Because you may say that this one is many because this one is a foreign key, right? But because this one is a foreign key, it could be many. But since this one is a primary key at the same time, that means this value cannot be repeated many times. So it cannot be many. It should be also one. So the foreign key here is to mention that this side is the weak side and this side is the strong, and it allows the repetition of the same primary key many times in this table. But because this one is a primary key at the same time, so it will guarantee that the foreign key value will never be repeated. It will have only one existence for every instance. Okay? Yeah, is that clear, guys?
Yeah.
Doctor, can you make an example for that? I don't,
For the one-to-one or for the one-to-many?
the one-to-one.
Okay, for the one-to-one is very easy. I give you an example last time, but maybe you forget. If let's say we have a system, for example, we are for example, we are a mini market or maybe supermarket or something like that that has a loyalty program which gives cards to the customers to identify them when they come and buy something from the market. Okay, so in this case they will have something called employees, right? Sorry, customers. Control Z, customers. Okay, so here it will have the ID, name, maybe card number, maybe phone number, and so on, right? So suppose that we have customer number one, name is Ali, and the card, for example, 1111, and the phone number is 2222, for example. Okay, then this one is the primary key. Okay, this one is the primary key. I don't know why I put it like that. So, this one is primary. The scenario is that in many markets or many systems, they separate the customers from the employees. Okay, and okay, I'm going to delete this. Suppose I would change the scenario for a little bit to make it easy for you. Employees table. Okay, so for the employees table here, we have the ID, name, maybe salary, and whatever else here, and this is the primary key, right? For example, we are talking about a very big mall, for example, or very big supermarket like Tesco, like Giant, or whatever. As you know, not all employees has access to the system, right? only the cashier or the managers has access to the system, but the normal employees who are working inside, maybe cutting chicken or maybe cleaning fish or whatever, they don't have access to the system, right? So they will have their information here, maybe ID number 1, ID number 2, maybe number 1 is Ali, number 2 is maybe Afif, for example, and their information here. Okay, what if we want to give access to Ali to access the system? So in this case we have two choices. The first choice is to create a username field and password field here, and in this case here we are going to give, for example, ABC 1 2 3 for Ali. Okay, this is a good design. Okay, good design. But the problem is that suppose that in a certain organization or in a certain company we have 2,000 employees. 2,000 employees. Then out of this 2,000 employees we have only 5 people or 10 people who has access to the system. So out of 2,000 employees we have only 10 of them are users in the system. Users in the system. So how many, suppose that this field is for example 18 character and this field is also 18 character. So in this case they would be 36 together, right? 36 character. 36 character means times 2000 minus 10 users, it will be 1990, right? 1990 times 36 characters, it will be a huge number. Okay, so let us take the calculator here. 1990 times 36 times every character is 1 byte, so it's supposed to be times 8 bits. It will give us 573,000 byte, which means 573 megabit. Or if we divide it by 8, it will be this one, it's supposed to be 71 kilobyte for only two columns wasted, right? Wasted 2 columns. So out of this we only use these 2 fields for only 10 users, only 10 users, while 1990 records will be empty. Why? Because that those users, those employees doesn't have access to the system. Okay, so in this case, to minimize the waste, actually the good design of the database is the design that could minimize any possible data repetition and also any possible storage waste. Okay, so here we are going to delete this part. I'm going to modify the design. So to make this design better, we better create another table here. We create only ID. So maybe this table is called users. Okay, and here we have username and password. Actually, it's when you create when you need to have users who access the system, you are not going to use the username and password only, because here you will have a very long sequence or series of columns to indicate many things. Maybe this one is active or not, because sometimes there's some users you disable. So active means ticked, inactive means unticked. Okay, then here maybe we have the list of permissions. Maybe this one is admin, this one is maybe sales, or whatever. It depends on how you design your permissions. But for now, I'm not going to consider this. I just want you to focus about the very simple scenario here. Okay, here we will have number 1, and the password of Ali is ABC, and the username is ABC, and the password is 1234, for example. So in this table, this is a primary key because we don't want to have 2 records for the same user. Okay, so this value will never be repeated. Then this ID is supposed to be existing in the other side. So here this enforces, or this requires a relation of one to many. Okay, so this one is a primary key and this one is a foreign key, right? Foreign key and at the same time is a primary key here. That means the relation is 1 to 1. So in this case, we will have only 10 records in this table for the only 10 users that we have. Here, you could say that we have a repetition here. We repeated this column while it's available here, right? But we repeat it only 10 times. 10 times, 10 users times the ID size, it's very little compared to 1990 records with a list of columns, right? So that's why separating the information into 2 tables is considered a good design that minimizes the data waste or the data repetition inside the database. Okay, is that clear?
Yes.
Okay. So here, if you have you taken the object-oriented programming last time? Have you taken the course?
Yes.
Yeah,
Using Java, right?
yeah.
Yeah,
Yes.
using Java.
Yes, yes. Have you taken the inheritance?
Yeah.
Inheritance. So you know
Yeah,
what's
we
the
have.
inheritance? When we have inheritance, we should have parent and child, right?
Yeah.
Yes.
Yes. Okay. In this case, this employee actually is parent. I just want to connect your ideas, okay, your thoughts together. It's not my responsibility in this course, but this one is good because I want to give you something that's really reflecting the requirements of the market. So this is parent and this is child. Okay, so you should create a class for the employee. Then after that, you should create another class with the user, with the name user. Then you should make it inherited from the employee. Why inherited from the employee? Because every user will inherit all of these fields from the employee. Okay, and this user cannot exist without the employee. Okay, but the employee will not have username and password. Only if you want to deal with the username and password, you have to have a user. Any question before I move? Okay. Keys can be simple as a single field or composite more than one field, as I explained yesterday. So the key could be single, could be composite of columns. Okay. Then keys usually are used as indexes to speed up the response to user queries. Actually, the keys, there is something called index. Separately from the key, we can go and create an index, and we decide what columns are involved for that index. But the key itself, when we create a primary key or a foreign key, then the key will create also an index, because the key is supposed to help the system to improve the performance and to speed up the queries. So if you find a system without a system of database that's designed, and maybe it's working in the real life, but the database has no primary keys, no foreign keys, then you make sure that this system one day is going to crash. Okay? And the system one day is going to be irresponsive. Okay? Why? Because the data is not indexed. The data is not properly structured. There is no relations, no constraints, so the data could be repeated. There could be many cases of inconsistency and many cases of repetition, and this is going to destroy or to crash the system sooner or later. Okay? If you remember at the beginning of this course, I showed you one of systems that I developed. This system, Uri.my, this one now is 57,000 members. This is only counted last week. 57,000 members. So this one, if you see now, it's responsive even though the server is very limited. The server is very limited because the budget of this project is also based on voluntary work. So we don't have a source of income, and we just try to handle the system. So if you can see here, the system is responsive while the server is very limited, has very limited resources, has very limited processor, very limited database, hard disk, and so on. But it's still working. Before I built this system, actually this system was designed by other person who is not an expert of building systems. So one day I was a member only in this system. Actually, I was a normal member. But after one day I tried to log into the system, I couldn't. I waited for the second day, for the third day, for 1 week. I couldn't log in. Really, when I tried to log in, the system showed me that circle that's moving, showing you that there's something is loading, but nothing finished. Nothing is loaded actually. So after I contacted the person in charge, I told him what has happened to this system, why it's not responsive, it cannot log me in. He said, we have this and that, we don't know what happens to the system. Last time it was working, but now we tried many times, we cannot fix this issue. Then when I visited the office, I discussed with them. I asked them to show me the database. When I see the database, I really shocked. Shocked. Why? Because the database has no relations, has no primary keys, has no foreign keys, has no minimization of repetition, no minimization of anything. Actually, the design was really a catastrophe. Really. That's why I convinced them that this system is not going to work anymore, because the size of the data is already huge. At that time, by the way, it was only 7,000 members, and it couldn't survive. So after that, I spent about 3 months with them to understand the system and design it. 3 months. Then during that 3 months, only 2 months was spent for the analysis and the design. Then after that, 1 month is spent by me only. I was the only person who do the software. I built this website in 1 month, and after that we released the new version of the system, and everybody was happy. And as you can see here, the performance is very fast, and we can see here many things could be shown quickly. Even though the database and the server are very limited, we can see that the database is responsive and it can retrieve data quickly. Okay, so here what happened after I redesign and build the software from scratch. I released the software in February 2018, the new version. Then after that, we started creating other subsystems. So we attached this, what they call it, blogs and communities, also what they call it, online teaching system. This one, Alim system, which is the online teaching system, and also the expert center of academic services, and also research groups. This one, scientific communities. This one is blogs and many things. This one is journals, and you can, as you can see here, we have 4 journals, and every journal has a lot of papers, and it deals with the editorial board, also with reviewers, with authors, and many things. Okay, so this could be plugged in, I mean, one by one, gradually, and the system will be, I mean, expanded gradually. Okay, but the main thing we have to do is to confirm that our design is correct from the beginning. We confirm that we use properly the primary keys, the foreign keys, the relations, constraints, indexes, and everything in a proper manner. Otherwise, the system will crash one day. Okay? I'm trying to link your ideas, your thoughts to the real life always. That's why I'm showing you this kind of experience. Okay, so the key can be simple, single field, and can be more than one field. Keys usually are used as indexes to speed up the response to user query. So the point behind using the keys is not only to make something unique, and that's all. It's only to speed up the system and to guarantee that there's no repetition will happen in the database. Okay, and the data devices or the storage devices is not going to be wasted. Okay, let us come here and see if there is an example about the primary key. Okay, the primary key, if you want an example for the primary key, for the single field of the primary key and the composite example, I can show you, for example, the order scenario. So the order here has ID. This one is the order stable, ID, date, then here maybe customer ID, and maybe total, maybe whatever here. Okay, it's supposed to have many columns. Okay, for the order, this one actually is going to be primary key. This one is going to be primary key, the ID. Okay, what's about the details of the order? The details of the order supposed to have a very long list of columns here. Let us start with the ID, order ID, which is here foreign key. Sorry, foreign key that comes from here. Okay, so this one is one-to-many relation. Okay, so maybe this one need to be like this and like that. Okay, this one is a foreign key. We not yet we talk about the primary key of this table. Then here we have something called, I will leave this one empty. Then we will talk about the Okay, let us take the item ID, IID. This IID is actually coming from other table, which is called items. I'm not going to show the structure of that table, but we only need to know that this one is one and this one is many. So this one is also a foreign key from other table. Okay, then here we have the quantity, maybe the price, maybe the discount, and subtotal. Subtotal. Okay, there's supposed to be many things here. Okay, it depends on the case. Okay, what if we have this scenario? So in this case, what is the primary key for the second order, for the order details table? Can you tell me what's the primary key? What could be a primary key?
OID and IID.
So you think these two fields are primary key, right?
Yes, I think.
Okay, this is correct. This is correct. But this is not the only solution. Why? Because in many cases, this will cause an issue. Okay, so in this case, if we use this design, so we make the order ID and the item ID together as a composite primary key for the order details. So in this case, if let's say order number 1 has item number 1 and the quantity 10, the price is, for example, 5, and discount is 0, and the subtotal is 50 here, then, for example, we added another item, maybe item number 2, and the quantity is maybe 100, and the price is 1, discount is 0, so 100 here. Then what if we want to add extra quantity of the same item number 1? So in this case, if we want to make 1, if let's say the customer wants to increase the quantity, so if they want to increase, for example, other 10 pieces, 5, 0, so this is going to show an error, because this one actually is a value that's repeated under the primary key combination. Okay, so this is not going to happen. Okay, it's not allowed to repeat the same item under the same order. Okay, the question here is it realistic scenario to repeat the item under the same order? The answer is yes and no. In some cases, they want the salesperson to be able to insert the item multiple times. Like when you go, for example, to the Hero supermarket, or to the KK, or to the 99 supermarket, when you bring, for example, 10 cans of Pepsi Cola. So in this case, they are going to scan can by can. Okay, so when they scan the first can, it will be registered in the system. Then the second can will be registered in another record, the third can. So the item ID is the same here, and the order number is still the same, right? So the item is repeated here. In this case, this is not going to work. This design is not going to work. Okay, but if the case is that they want the salesperson to modify the quantity, if the user wants to change or to add extra quantity from the same item, in that case, this design is very good. Okay, is that clear?
Doctor,
Yes,
can
it
you
does.
repeat?
Can I repeat what? Everything?
Can you the primary key condition
Yeah, in
on the
this case, suppose that this one is Pepsi Cola. Suppose the second item number 2 is 7-Up, and the quantity here is only one piece. One piece here, and here also one piece, and here is also one piece. The scenario is like this. Suppose that you went to the supermarket, maybe 7-Eleven or maybe KK or 99 or whatever supermarket, and you bought 2 cans of Pepsi Cola and 1 can of Sprite or 7-Up. Okay, suppose that the Pepsi Cola is ID is 1 and the 7-Up ID is 2. Then when you bring it to the counter, you put it on the table and the salesperson take the first can of the Pepsi Cola or the what they call it, Pepsi. Sorry, I say Pepsi Cola because you don't have Pepsi Cola here. Okay, if the first can was Pepsi, they scan the Pepsi can, it will be recorded in the system, right? Order number 1, Pepsi can. Okay, then suppose that they take the 7-Up can, which is under the same order, but the ID number is 2, and after that they take the third can, which is Pepsi as well, and it will be recorded like this, 1 and 1. So in this case, there an error is going to show up here. Why the error is going to show up? Because this supposed to be a unique value. The combination of order ID and item ID is supposed to be unique because these two we put them as a primary key, right? So they shouldn't be repeated. They shouldn't be repeated. The Pepsi could be repeated under other order. It can be repeated because here the value is not the same, right? But under the same order, we cannot have 2 records for the same item. So if this is the case, if let's say we want the system to show as many records as we scan, then in this case, this design is not going to work. But if we scan, for example, the Pepsi can at the first time, it will create this record. Then when we scan the second can of the Pepsi, it will check either this item is available in the same order or not. If it's available, it will +1. So this will be 2. Okay, sorry, this one will be 1 and the quantity will be changed to 2. Then it's okay. It can work. But we have to do some kind of checking at the system, at the application layer. Okay, at the application layer, at the software, we have to check either the item is available under the same order or not. If the item is available, exists, I mean, then we have to increase the quantity of the previous record. We cannot key in a new record with the same item ID. Okay. Otherwise, if we want to allow the repetition of the record, this record, then we have to insert something here, to insert another column here. Okay, we have to insert another column here, and this column could be also combined inside the primary key. So maybe this one we call it maybe index, and we generate this automatically. So in every record, if this record is 1, the other record is 2, 3, 4, and so on. So in this case, the same item 1, okay, the primary key will be 1, 1, 1. But in the second time we scan the Pepsi Cola can, the Pepsi can, we can see that the value of the primary key is already changed, because here the index or the record number is 3 with 1, 1. So 3, 1, 1 is not the same as 1, 1, 1. So this could work properly. Okay. Is that clear?
Okay. Yes, but if we did this way, the generated 1, 2, 3, 4 here, it will take more space, right? It will take more data, right?
Yeah, also this will be a kind of repetition, right? Because the item ID is repeated here with different quantity, so we can combine them together. It's up to the requirements of the system. Why they some systems they require this? Because some systems they have the policies of selling items like buy two items, then you get 50% discount on the third item. So in this case, the two items of the same number will be, for example, the price will be 5 ringgit, but the third part will be only 2.5. So in this case, you have to repeat the record. You understand why?
Okay.
Yeah. So
Yes.
because in the real life there are many complicated scenarios. So that's why when you start designing a new system, you have to carefully understand the system, carefully get the proper information from the responsible people of every small task. So if let's say you are trying to build a system for a mini market, then you have to go and talk about the policies of selling the items and the promotions, and do they have vouchers? Do they want to give special discounts like buy two and free one, something like this? You ask about everything. Then you should meet also the person in charge of the sales department. You ask about every possible policy of selling things in order to consider them. Otherwise, you may design the system, you may build the system, and you submit, you give it to them, you install everything, and you give them training and so on, and they start. And after a while, they want to create a promotion, for example, like buy two and free one, or maybe buy one, get second and get discount on the second part, or maybe what they call it. There are many things. Uh, when they try to apply this kind of promotion, the system cannot provide this, or maybe shows an error. In this case, you have to go back and you have to re-structure the system. You have to recode your application, and that is going to waste your time too much, because modifying things is more than creating them, is taking time more than if we create them from scratch. Okay, that's why carefully understand everything properly from the user, from people in charge, and so on. And after that, you create your initial design. You go and discuss with them. You try to think about any possible scenario. If you don't have enough experience about a certain business, then you have to try to visit similar supermarkets, and try to ask about the maybe the possible promotions or whatever they have. Try to ask about it, and what if I buy one from this, and what will happen if I do this. Try to ask, try to see, try to watch everything, and how the, the employee scan things, and what's the bill looks like, and so on. Okay, then you will build a very good experience, very good idea about it, that will allow you to start your design. Okay, is that clear?
Okay, clear.
Yeah. Okay, let us move on. So here, the transforming of entity relationship into relations, step number one, because here we have many steps. Okay, now we have to go through the step number one. Step number one is mapping regular entities to relations. So simple attributes, entity relationship attributes map directly onto the relation. Okay, if let's say we have this design, how we can map this to a real relation? Okay, let us take the car scenario. Or the car scenario is very easy. because the car scenario is what they call it, very easy, very simple here. That's why we don't want to check it. We don't want to take it as an example. But here, for example, the customer, we have two complicated things like the name, which is composite attribute, and also the address is a composite attribute. Okay, let us take this as example and try how to map it. Okay, for the customer, I'm going to change the color. For the customer, actually, the table is going to be like this. So here we have the ID. Then we have the first name and last name here. Then the address also is going to be broken down into small pieces like postal code here, house number, then city, and after that the state, like that. And this one is going to be primary key because of this. Okay, this is how to map the attributes into a relationship. Is that clear, guys?
Yeah.
So when we map, we never map the composite attribute. Composite attribute is not going to be mapped into the table. Okay, is that clear? This is the first step actually. Okay, so let me clean this. Let's go back to the slide. Oops. Okay, simple attributes should be directly mapped into the table, and the composite attribute use only their simple component attributes. As I mentioned here, the composite attribute is not going to be mapped. We only use their own sub attributes. Okay, then here, close your mics, please. Close your mics. Open only when you have a question. Okay, so also multi-valued attribute become a separate relation with a foreign key taken from the superior entity. Okay, let us get an example here. We have the damage amount, right? This one is a very complicated scenario. There are other scenario in our slides, in our previous slide, I think, here. I'm going to take that because that one is easier to understand for you. Here, yes. Okay, this example, in this example, they have employee ID, employee name, address, years employed, which is what they call it, derived, and this one is a date employed, and then we have multi-valued attribute here. So this multi-valued attribute is going to be changed, or is going to be translated into another table with a foreign key to primary key relation. Okay, so let us start the design of this thing here. I will draw it quickly. So here in this table, we have the employees, table. Here we have ID, name, then employee date, then what else do we have here? Address and address here. Okay, suppose this is only the information. So here, what is the primary key? The primary key is this. Primary key is this. We should put an underline to mention that this one is a primary key. Then the skills shouldn't be attached or mapped to this table. Why? Because every skill has sorry here, because the design here shows that this skill is multi-valued. So every employee could have a single skill or multiple skills. Okay, that's why we need to create another table like this, and we call it skill ID, then employee ID, like that. Okay, and here the skill name or the skill description. Okay, so here if let's say employee number 1 name is Ali, and the date is whatever, the address is whatever, and we have, for example, number 2 Hafif. So in this case, suppose that the first entry will get skill ID number 1. So the employee ID, for example, Ali, suppose that Ali is having C++ and also Java and C#, for example. So in this case, they will have, or let us remove this. We keep only 2 because the space is very limited. So here Ali, this one is Ali, or maybe we make this 11 and 12 to differentiate between it and the skill ID. So Ali has skill number 1 is Java, for example, and skill number 2 for Ali, skill number 2 for Ali is C#. Okay, here, are you with me, guys?
Yes.
Yeah, because here is very important, because this one is the first time scenario. The scenario, this scenario is first time I explain. It's very important to understand. So in this case, until now everything is going smooth, right? But what if this guy number 12 is also having C#? So in this case, the skill ID is going to be with different number, right? 3 maybe, or 2, or what we can do here in this case definitely is complicated, right? And also the other thing, maybe at the beginning the C# is written like this, C space sharp, maybe in the other time, the second time we write it like that, C then the hash character immediately without any space. Okay, so in this case, if let's say we want to search about people who has the C# skill, then if let's say in the in the search keyword we write C space hash, then it will show us Ali only, while we also have Afif who are skillful in the C#, right? So this will cause a problem. Why? Because the data here is considered inconsistent. Okay, and also the same skill here, C# is under number 2 here, and the C# again is under skill number 3. So if let's say we have 100 employees who are skillful in the C#, then we will have 100 numbers for the same skill, right? And this is totally totally wrong. Okay, this cannot be used in the real life. That's why instead of this, I'm going to show you a very best practice scenario. You really, it's this kind of scenarios is not available. If you go to any place, if you read any book, you cannot find this kind of scenarios that's really coming from the real life. Okay, so here we have to create another table. We have to create another table called skills table. Okay, ID, name. For description, no problem. This one actually is a primary key. This one is going to be 1, 2, 3, and so on. So in this case, if let's say this one is 3, here's C#, maybe here's Java, here's C++, and so on. This one is, let me clear this one because I want to change the sequence of the table, the columns to make it easy to draw. Here we have 2 columns only. One column is the employee ID, and the other column is the skill ID. And this table is called skills. This is a primary key here. Okay. Here for the first employee, if let's say Ali 11 is skillful in C#, so we have to save the number here of the C#. If Ali is also skillful for the with the Java, then we have to create another record like this. Then if let's say Afif number 12 has also C# and has also Java, then the C# and Java will have the same name and the same ID. Okay, and also the Java has the same ID. Then the name here, if the name is written as C space hash, it is going to be used for both, because then the same name will be retrieved instead of the ID. Okay, and also if we need to modify this name in the first scenario, we will have, if let's say we have 100 employees who have the skill of the C#, then if let's say we want to modify, because some of them has a space, some of them has no space, or maybe some of them is written like C# and the sharp is written as SHARPE, sorry, RAP, then we have to make it unified. We have to change the name to make it unified. In this case, we have to go and modify 100 records for the C# only. Then if the Java is also written in different way, then we have to go and modify every record that has Java. But in this case, if let's say we want to change the name of C# with the space or without space, or maybe we write instead of hash, we write SHARP, then in this case, we need only to go to this place and we modify this only. So this design actually is better than the previous scenario. Also, the ID of the C# is the same here. The C# has only one ID, no matter how many records. And also the Java has the same record, no matter how many records they have and how many employees having the skill of Java or C#. Okay, in this case, because this one is a primary key and this one is a primary key, this one is actually related here and this one is related here. So this one is a primary key side, which is 1, and this one is a primary key side, which is also 1. So this side is supposed to be many, because every skill could be assigned to many employees, and every employee could have multiple skills. Okay. Then the relation here, the general relation, or the main relation between the employee and the skills is many to many. Okay. Anyway, the primary key of this field, of this table, is the combination of the two fields, while this one, the combination is a primary key, and this one alone is a foreign key, because these values have to be exists in the skills table, and this one alone is supposed to be also a foreign key from the employee. Okay, this is how it works. So you can see from that design, from the choose what they call it, cruise foot model, we have only one circle here with double line, but this one circle with double line uh, creates a lot of headache to us, and we have to know how to make it and how to avoid the possible problems that could happen. Okay, is that clear, guys?
Yes, Doctor.
Yes, Doctor.
Okay, any question?
So far, no.
So far, no. Okay, so we need to delete this, or maybe we keep it. We don't know what's going to come in the next slide. Okay, so here to summarize, simple attributes have to be directly mapped to the table, right? Composite attributes should use only their symbol or their sub components. So for example, if this is used, so the name is not going to be mapped, the address is not going to be mapped, but instead of the name we map the first name and the last name, only the sub attributes. And here for the address we map only the sub attributes as well. And for the multi-valued attribute, we have to create another table, at least another table. Then we create a foreign key relation with the main table. Okay, so that's all about the first step. Here, let us take this example. So in this case, because the customer entity has 3 simple attributes, so these 3 simple attributes are going to be mapped into the table. Okay, when I ask you to map or to create the first step, it's up to you to draw the table like this or to write it in this way. But also, if you want to write it, you have to give me the table name, customers. And the name, as I mentioned, the name here is supposed to be plural. The name of the table, it's wrong if you use the table name in singular. It's going to create some issues for you, because in future when you go to the application level, you will have 2 types of the customer. One type is the customer set, which represents the table, and the other type is the customer row, which is the instance of every customer. So the customer row is supposed to be singular and the customer set supposed to be plural. Okay, and the customer set is exactly the table. Okay, especially if you want to use MVC framework or maybe any other framework that make your programming easier and more clean, then you will face a lot of problems. Okay, so better table name is supposed to be plural, column name is singular, and the entity name in this kind of diagram supposed to be singular. Okay, then here we go to the other scenario. In this scenario we have customer but with different types of attributes. So we have here the what they call it, the composite attributes. So as you can see here, we don't have a customer address, but we have street, city, state, ZIP. So we use the subs only. Okay, in the third scenario, mapping a multi-valued attribute, it's supposed to be like this. So here you see they in this scenario here they mention only the skill as also a primary key, but they did not mention either this skill is a string or number or whatever. Is it coming from this table or coming from another table? The example is not very clear, but based on my explanations is more clearer. Okay, so the skill have to be mapped to other table with the relation of 1 to many. So the employee is 1 and the skills is many. Okay, then here we have the second step. The second step is mapping weak entities. Mapping weak entities becomes a separate relation with a foreign key taken from the superior entity. As I explained in many scenarios, when we have a foreign key, when we have a strong entity and weak entity, then the relation, the side of the relation at the strong is 1 and at the weak is normally going to be many, or sometimes is 1 if the relation is 1 to 1. Okay, so become a separate relation with a foreign key taken from the superior entity. The superior entity is the strong entity. Okay, primary key composite of partial identifier of weak entity, primary key of identifying relation strong entity. So the primary key of the weak entity supposed to be the combination of the strong ID, the strong entity ID, and the weak entity ID. Okay, this already explained many times in many examples. That's why I'm not going to waste too much time here. Let us move to the example here. So here we have employee and dependent. So the employee should be the man who has a wife and children, or maybe the woman who has a husband and children. So the husband and children will be dependent, right? So here, this relation actually is going to be mapped into 2 tables. The first table is going to be the employee, and the second table is going to be the dependents. So here, let us move to the second slide. We can see that the employee has the employee ID and the employee name. This is the minimum requirements of the employee table. Then here, note the domain constraint for the foreign key shouldn't allow null value of dependent if dependent is a weak entity. Yes, this one, the foreign key field shouldn't allow, in this case, shouldn't allow any null value. So we couldn't have a dependent in our system without employee. Okay, in this case we shouldn't allow the null value for the employee ID. Okay, then here we have first name, middle name, last name, employee ID, and we have date of birth and also gender. Okay, so in this case, as they put in this example, they make a composite primary key using the first name, middle name, last name, and employee ID as a primary key. Okay, to avoid any kind of duplication of dependents. So actually, because naturally in every family we never have 2 kids with the same first name, right? Is it right or not?
Yes.
In the same family, we never have 2 people with the same 2 kids with the same first name, right? But the middle name is repeated, the last name is repeated. They mostly use the same middle name and last name, right? So that's why involving the middle name and the last name into the primary key is only a wasting of resources. Is only complicating the system. So it's more than enough to keep the first name and the employee ID as a primary key. Okay? But this works also. This also can work. But to simplify, we have to think about the reality and the real cases and how it could work. If let's say in our community in Malaysia, for example, in the family we never have two people with the same first name, then it could be first name and employee ID only. But if let's say in other countries, it could happen. They could have two kids with the same name. So in that case, we have to consider another issue, because also if they have the same first name, the middle name is going to be the same, and also the last name is going to be the same. Then it's not proper to be a part of the primary key. So we have to look for different thing, maybe date of birth, or maybe other thing, maybe IC, maybe passport, whatever. Okay, understood?
Okay, Doctor, clear.
Then we have step number 3. Step number 3 is mapping binary relationships, one to many, many to many relation, and one to one relation. Okay, for the one to many relation, primary key on the one side becomes a foreign key on the many side, right? As I explained in all scenarios. So this is a one to many relation, right? One here, one to many relation, right? So the one side, the field of the primary key at the one side have to be a foreign key at the other side, at the weak side. So this one is a foreign key, right? Here, the primary key here is supposed to be a foreign key in the other side of the many. Okay? Also, many to many should create a new relation or a new table. This one, the many to many relation should involve a new table with the primary keys of the two entities as its primary key. Okay, let us go to this scenario. Okay, this scenario is here. From here to here is many to many, right? In the first type of diagrams, if we want to use the cruise foot model, so it could happen to have many to many relation between two entities directly connected to each other. But when we want to map them to a real database, we have to involve a table at the middle. Okay, so this one is many side, right? But here we have a primary key, and also this one is a many side, and also we have a primary key. So we should have this primary key, and this primary key together in the middle table as a primary key, right? Both of them should form the primary key here. Both of them should form the primary key, and each of them supposed to be a foreign key. Each of them supposed to be a foreign key. I think this is very clear, right?
Yes.
Okay. For the one-to-one, primary key on the mandatory side becomes a foreign key on the optional side, and also a primary key at the same time. This one becomes a primary and foreign key at the same time. So if you remember the scenario of the employee and user, they have like this. This one is the employee, and this one is the user. The employee has an ID, right? And the user also has an ID. So this one is a primary key, and this one is a primary key based on itself, and also a foreign key which requires that the values here must be exists in this table. So this side, because this one is the mandatory and this one is the optional, okay? So the side of the optional, the primary key is supposed to be a foreign key from the mandatory side. Okay, is that clear, guys?
Yes, Doctor.
Okay, let us see this example. Relationship between customers and orders. So here the customer, one customer should have multiple orders, but one order supposed to be belongs to only one customer. But the customer is mandatory for the order, and also the customer could have orders and maybe doesn't have orders, but this is not the case. This is not a real case. The real case is to have here, instead of this option, we supposed to have mandatory meaning, because once the customer is saved in our system, it's supposed to be saved at the first order, right? When he or she came to make the first order. Otherwise, this customer will never be saved in our system. Okay. So here the structure will be like this: customer ID, customer name, and customer address. The customer ID is a primary key, and here in the order we have order ID and order date. Then we have customer ID, and as you can see, we have the dashed line under the customer ID to mention that this customer ID is a foreign key that comes from the strong customer entity. Okay, is this clear?
Yes.
Okay, let us take the other scenario. Here we have many to many, diagram of M to N. Okay, here we have vendor who supplies raw material. So from every vendor we could get multiple materials, and also every raw material could be supplied by multiple orders. So the relation is many to many. Okay, so here as we can see, material ID, unit of measurements, standard cost, and the supply will supply based on the unit price. And also after that we have the vendor name, vendor address, and vendor ID. And okay, the first thing, could you tell me what is the first thing that we have to do here? We have to create a material table and vendors table, right? And what we have to create more than that, we have to create a table for the supplies. Okay, we have to create a table for the supplies. Then we go here, we can see the scenario. So raw material is like this: material ID, standard cost, unit of measurements. Then we have the vendor, vendor ID, vendor name, and vendor address. Then we take the primary key from the vendor, we put it here in the middle table. We take also the primary key of the material, we put it here at the middle table. Then we include the unit price, and we take these two foreign keys. Material ID is supposed to be foreign key, and vendor ID is supposed to be a foreign key. These two foreign keys supposed to be the composite primary key, and here is a symbol attribute is going to be attached to them. Okay, is that clear?
Yes.
Okay, the third scenario, or the third case here. So relation of one-to-one. We have a nurse, we have a care center, and every care center should have only one nurse, and every nurse should be responsible for one care center maximum. So the nurse could be responsible for a care center, or could be not responsible, because this one is an optional side. So which is the strong side now? The strong side is the nurse, or the mandatory side is the nurse. And also it could be the opposite way. The care center could be the strong type. Depends on how you think about it. So the nurse type here is the mandatory here, and we have nurse ID, the name and date of birth. Then we have the care center, which is care center name, location, nurse in charge, date assigned. Okay. So here this is a primary key. The nurse ID is a primary key, and here the center name is a primary key for the care center. But here the nurse in charge is actually a foreign key from the nurse ID. But this case actually will ensure that for care center, only one care center, it couldn't be entered into the system more than one time. So the care center is guaranteed that it cannot have multiple instances. So the side of care center is guaranteed to be one. But the side of the nurse, which is a primary key, the nurse ID could be saved under the same under different care centers. So for this case, for this scenario, it's not guaranteed. It's not guaranteed it's not guaranteed that the nurse side is one. So to avoid repeating the same nurse ID with different care centers, we have to mention something other than this. We have to mention that this field is unique. Okay, this field is unique. Don't confuse, okay? So the nurse in charge must be unique to guarantee that every nurse could handle only one care center, because based on this diagram, the nurse is mandatory one and the care center is optional one. So means every nurse should handle maximum one care center. So in this case, if we make it like this, if we make it unique, that condition is going to be guaranteed. But if we keep it open like this, without the unique feature, without the unique property enabled, then every nurse could be responsible for multi-care centers. Okay, this is one case. The case of the employee and user, the user ID actually is primary key, and the primary key implicitly is unique, right? So the important thing is not to keep in the relation of one-to-one, is not to keep the foreign key as a primary key. It's not necessary, but it could be unique without a primary key. Okay, is that clear, guys?
Yes.
Yeah, because in this case here we deal with two different types with a relation of one-to-one. So the first table, the second table is not an extension to the first table, but the scenario of the employee and the user is the case of extension, the case of table extension. And also that case is reflected in inheritance when we talk about the object-oriented programming. But in this case, this is not a case of inheritance. Why? Because this one nurse is one object and the care center is another object. Okay, so this is what they call it a navigation property. The nurse in charge is a navigation property. Okay, not an inheritance case. The inheritance case is only when the primary key is the foreign key at the same time. Okay? Step number 4 actually is not, there is not enough time to explain this. I'm going to stop here. Stop. Okay, so that's all for today. If you have any question, please ask me now before we close, and otherwise I'm going to close and see you for tomorrow, inshallah. Any question, guys?
No.
Do you think you learned something new today?
Yeah.
Okay.
Relations.
Yeah, that's very good. So to recap, before we finish this class, to recap, today we learned the 3 steps of transforming the entity relationship into relation. So the first thing we learn about the definition of the relation. The definition of the relation is a table with 2 dimensions. So the columns are considered attributes or fields. The rows are considered instances or records. Then we have some requirements. So the names supposed to be unique, attribute value supposed to be atomic, row is unique. That's why we require to have a primary key, and also columns in the table have unique names. Then the order of columns is not matter, and also the order of rows is not matter. Then we have this scenario, how to fix it, and we talked about the repetition of data here and how to avoid them. Also, this scenario have multiple values in the same cell and how to fix that issue. Then we talked about how to avoid repeating the data, because repeating the data, if let's say this manager ID, manager number is changed for the department 101, so you have to go you have to go for all employees and change this ID for them. So this is going to be a massive work, and this kind of work is prone to errors actually, because sometimes you forget to change 1 or 2, or maybe change wrongly. Instead of 1 2 3 4 5, you make it 1 3 2 4 5 or whatever. Then you will have the system in an inconsistency situation. Then here we have the correspondence or with entity relationship model. Just forget about this slide. Then we talked about the keys. We learned about the primary key, foreign key, and what is the benefit of using them, and also the keys how can be simple or how can be composite, and also the keys are used for indexing to speed up the response of the query. Okay, then we started the transforming of the entity relationship into tables. Then we learned about the first step, which is mapping regular entities to relationship. How to map the simple attributes easily, directly we map the simple attributes, but the composite we take only their sub components and we map them to the table, while the composite attribute itself is not going to be mapped. So for the multi-valued attribute actually is going to create another table with a foreign key to primary key relation. So the table itself will be superior, and the other table will be weak type, as we have learned in many cases. So this is the scenarios. We have taken these scenarios. And we came through to the second step, mapping weak entities, how to map the weak entities. So the weak entity becomes a separate relation with a foreign key taken from the superior. Then the primary key composite of partial identifier of weak entity and the primary key of the strong entity. Then here we have some examples how to make it, and this is step number 3. So how to map the binary relationship, how to map the one-to-many relation. So the primary key of the one side supposed to be a foreign key to at the many side, and also many-to-many supposed to create a new table at the middle, what they call it middle table, to form the many-to-many relation. So that middle table should have the primary key of both tables of the many-to-many relation. If we have only 2 tables of the relation, but in some cases we have many-to-many, that's ternary. Ternary means maybe 3 tables or 4 tables involved in the many-to-many relation. In this case, we have to take the primary key from every table and we put it in the middle table. So if let's say we have 4 tables involved in the relationship, then the middle table should include 4 foreign keys from the main primary keys of the 4 tables. Then we take the one-to-one relation. So the one-to-one relation, the primary key on the mandatory side become a primary, and foreign key on the optional side. Sorry, this one is not a primary, become a unique, and foreign key a unique and become unique and foreign key on the optional side. Okay, this is the scenario of the this one is the scenario of one-to-many, and this one is the scenario of one-to-many, how to make it, and this is the many-to-many, how to create the middle table, and then the scenario of one-to-one and how to make the foreign key and how we make it a unique. Okay, then we stopped here. Is that clear, guys? It's exactly 2 p.m. So we already finished 100% of the time. Sorry for not giving you any break, but that because really I want to achieve something with you. I want you to learn very good practice, and I want you to become very strong in this matter. Okay, guys. So if you don't have any question, thank you very much, and I'm happy to have you all in my class, and hopefully, inshallah, I see you tomorrow in good health, inshallah. Assalamu alaikum wa rahmatullah. Thank you.
Salam. Thank you, Doctor.
Thank you, Doctor.